Test 1, 2, 3. Good afternoon, guys. How are you doing? I appreciate you coming, especially after the after party. We all know how it is. So good to see you, good and alive. Today we wanted to talk about proxy patterns. So this will be more of a technical workshop. It not will be like hands-on live coding, anything like that, because I do believe like this topic is way too broad and way too complex for a 30-minute presentation. However, the goal of the presentation is to basically encourage some people that are already into smart contracts development. Maybe they've heard something about proxies, but they think it's, I don't know, unsafe, it's some magic, they don't quite understand how it works. And the possibilities that proxies give you are almost limitless and limited by your imagination and EVM. So we'll quickly go through like the basic examples of simple proxy patterns, simple proxies, what it is, how it works. But I want to finish with the Diamond standard, which is a bit less known still to the developers. But I think the possibilities that it gives you are just amazing. My name is Kamila Muca, I'm CTO at Delta Prime. I highly do encourage you to check out our website, our docs. Gavin, our CBDO, did like a good work on documenting everything that we do. But that's for later. Let's start with the important stuff. So what is a proxy contract? I'm sure you're familiar with the fact that once you deploy a smart contract to the blockchain, it's immutable, meaning that there is not much that you can do with it. You cannot really amend it, change its code. Well, you can destruct it if you allow for that, but that's pretty much it. However, we also know that even in Web 2 or just like software development, hardly ever you're able to create like one version of code that will work perfectly, that will not need to be like changed. Maybe there are some bugs that you need to fix. Maybe there is some new functionality that you want to add. With smart contracts, that's not really the case. And it also has upsides, right? Because like if there is a smart contract that you know it works, it's safe, it's proven over the time that it works, you feel confident because you're interacting with the same address, with the same code, you know what to expect. However, there is also this need that I mentioned for the upgradability of the code, so we can add new features or do bug fixing or many different great things. All of that needs to be said that if you have upgradable contracts in your protocol, you need to take care of things like, for example, time lock. Basically a way for users to experience the positive sides of the upgradability of the protocol, that you are able to deliver new features, bug fixes, stuff like this, but at the same time feel safe that out of nowhere you will not just like change the implementation, change the code, rug pull them, your users. So there are like things to keep in mind when developing this kind of architecture. Basically having a way for your users to see when the changes are coming, being able to see what's changed in the code. Preferably it should be audited, because we cannot expect all of our users to be like security experts, solidity experts. At the same time, we want them to feel like safe and secure. So there are like many topics that you should think about while implementing upgradable infrastructure architecture. But this is not the topic of this presentation, just something I wanted to make you aware of. So what is a proxy contract? If you think about it, it's in the simplest form, it's basically you deploy two contracts, the proxy contract and the logic implementation contract. Whenever you interact with some contract on blockchain, you basically interact with a certain address and you send a transaction with call data to that address. And what proxy does, it's basically in its storage, it stores an address of the implementation contract, and using the great solidity feature of delegate call, it basically delegates your call, your transaction with all of the call data to the logic contract. What it means is that it executes the code from the logic contract in the context of the proxy contract, just as if you would write the code inside the proxy contract. It may sound like confusing at the very beginning, but once you wrap your hand around it, it actually makes sense, right? Because like if you write code in the logic contract and let's say it modifies storage, it will not modify the storage of the logic contract, it will write directly into the storage of proxy contract because it is being executed in the context of the proxy contract. And you could say, well, that's great, that's good, but like if this is the same as if I were to create that code inside the proxy contract, why even bother with having like two contracts? More gas, more hassle. The thing is that the address of the implementation contract you store it in a storage of the proxy contract. So this thing you can change. It is mutable because it's storage. By doing so, you can basically point to different implementation contracts, and their code will be executed every time in the context of the proxy contract. By doing so, basically you achieve upgradability. You're able to add new functions or completely change the implementation. This is why it's important to have like time locks and security measures in. But this finally, despite contracts being immutable on their own, gives us a possibility to work around that, to update the code, to do some bug fixes. There is also a couple of things to note when you're working with upgradable contracts and proxies. For example, storage collision. Because if you are aware how EVM storage, default storage layout works basically, it works in the way that if you define like variable 1, variable 2, address, uint256, whatever, it will occupy the slot 0 of the storage, then 1, then 2, and it happens like every time. So if your proxy contract uses the first slot of the storage to store the address of the implementation, but the implementation contract uses also the first slot of storage to store, I don't know, number of points, number of Dogecoin, whatever. It will basically write to the same place in the memory as the storage, as the address of the implementation contract it proxies is written to, and it will create a disaster. So whenever working with contracts, you have to either be really wary of how you structured the storage in both proxy contract and implementation contract. Well, this can be troublesome, right? So what people find is a better way. Basically, you can calculate a Ketzak hash of any arbitrary string. In this example, that's EIP-2535 proxy beacon. This could be really anything. And this guarantees us with enough probability that the slot to which we will write, and you need to use assembly or YUL, but it's really just like telling, okay, this variable uses this slot. And by this slot, I mean the result of the Ketzak hash. Then basically it will be stored somewhere random, let's say, random enough in the storage to avoid collision. What's more is that if you are going to familiarize yourself with proxies, if you're thinking about using them, you should really understand how they work. It's not magic, it's not rocket science, but it is really important that you know exactly what's happening to basically avoid like being exploited or avoid any functionality that would work differently that you thought it will. So OpenZeppelin, for example, they did an amazing job with like documenting the standard proxy types, proxy design patterns. They have like both contracts that implement this and also documentation that goes really deep on how exactly it works. So one of the things that they've also upgraded is the admin functionality, where you have an admin of a proxy, like an owner of a contract, basically. Only that admin, that externally owned account or some other contract is able to change the implementation of that proxy, basically, like the address at which the implementation is stored. But what happens is that basically it only allows admin to call the admin functions. And if the admin account tries to interact with the methods in the implementation contract, it will revert. And the same way around. If you are a normal user, not the admin, you can interact with all of the functions that the implementation contract exposes, but you're not allowed to touch the functions of the administrative functions. Thanks to that, we also do get rid of the situation where in the implementation contract, you would have a method named the same as in the proxy contract, like implementation or admin. This is also like one of the things that you should consider, basically a clashing in between names or basically selectors of the methods in the proxy and in the implementation contract. But thanks to this transparent upgradable proxy, you don't really have to think about it that much because it does it for you. But now that we know more or less how it works, the fun begins, because this is like primitives, this is like building blocks that you can like innovate upon, build on top of that, and that's what I love. So we have simple proxy, but let's imagine a scenario in which basically you want to deploy one proxy contract per user for whatever reason, like this is the business logic, this makes sense from the like architectural perspective. So every user gets their own smart contract. And this is a proxy contract with their own separate storage, with all like separate ownership of any tokens, because we know that, of course, contracts can also like hold tokens. And The proxy on its own, it's only as useful as the implementation contract that basically brings it to life, like gives like some functionalities. So let's imagine that you have 10 users. You deploy 10 proxies, and you have like one implementation contract, and all of the proxies point to the same implementation contract. That's great, it works. And you want to add some change or change the implementation contract. Well, you can do that, but now what you need to do as an admin of those proxies, you need to go there and you need to update the implementation address in proxy 1, 2, 3, 4, 3, 10, doable. If you have 100 users, if you have 1,000 users, this gets a bit tricky, right? Like, it's not really what you want to do. But what you can do is use the upgradable beacon or like beacon proxy pattern. Basically what it does is instead of storing the address of the implementation contract inside of the proxy only holds the address of so-called beacon contract. And beacon contract is simply a contract that all it does, it stores the current implementation address and it returns via like a view method if you ask for it. So then when every proxy contract holds the address of the beacon, before doing the delegate call, it just uses the normal call. It asks, hey, beacon, what is the current implementation address I should delegate my call to? And it returns the address. And then to that address, written from the beacon, every single proxy will delegate call to the implementation contract. By doing so, you will have like a single point in which we can upgrade the implementation contract. And by doing so, by changing this only in the beacon, we do upgrade all of our proxies, no matter if it's 1, 10, or 1,000. Pretty cool, right? But that's just the beginning. So if we go further, we will find the diamond standard. And to me, this is like a great innovation because as far and as much as the beacon proxy pattern and proxy pattern are great, there is this EVM limitation that sooner or later when you're building smart contracts you will stumble upon. Max contract size limitation. I don't know if you've been in this place, probably some of you, yes. You are creating the best protocol ever, the best contract ever. You just want to add one more event or one more function, that will be it. Whoops, oh, that's right about, I don't know what I'm looking at my watch, but let's say it says how big this smart contract is. 25 kilobytes, that's okay, now 26, oh, sorry, cannot deploy. You can of course compile it, but you cannot deploy it because this is too big. But what if I told you there is a way around it? And there is. So the good thing is that there is a diamond standard. It works similarly to the beacon proxy pattern or just proxy pattern, but instead of storing a single address of the implementation contract, it basically stores a mapping of function selectors, or you can think of it like function names, to the address at which a given function is implemented. By doing so, we can basically implement our logic and spread it across arbitrary number of contracts. It can be one contract, it can be 10, it can be one contract with one function only, another contract with 10 functions, and the beacon, basically the diamond, will keep track of every single function that we added to the protocol and will redirect and return the correct address with the implementation. By doing so, user still interacts with a single address, with a single contract only, but thanks to delegate call and thanks to Diamond, now it has the possibility to interact with arbitrary number of like logic implementation contracts, so we are no longer limited by the maximum size. And this is something that we use partially in the Delta Prime architecture, because what we did is we combined beacon proxy pattern and the Diamond standard. This is one of the things that I love about like Web3 and blockchain and Solidity and contracts like in general is the composability, very hard word. Composability, basically, it allows you to build like a building block, so one on top of another. You can either come up with new primitives and innovate, or use the existing ones, connect them, and build something totally new. So what we did is basically we recreated this architecture where for every user we deploy a new dedicated smart contract, and it acts as an escrow account. Maybe 2 words about Delta Prime, because I didn't mention it at the beginning, but if you don't know yet what Delta Prime is, it's basically like a DeFi native prime brokerage where you can have access to under-collateralized lending, capital efficient, extra liquidity, and then invest into the different integrated protocols. The funds that you borrow and the funds that you deposit as collateral, they are not sent to your wallet directly, because what we do, let's say you come to Delta Prime, deposit 100K, then you borrow 400K. If we were to send the 400K to you, it's not such a good deal for us because, well, basically, we don't know who you are, it's trustless, it's decentralized, so you could say, thank you very much for the 400K, see ya. Right? So we cannot do that. So this is why we create this proxy contract that has custody over the assets, both the 400 that you borrowed and the 100 that you deposited. And then the user can interact with the contract and basically steer his investments, like liquidity provide, mint GLP with that, or swap tokens, do delta neutral, delta mitigating strategies, this and that. All of that is possible because we have this implementation in which the proxy contract asks a diamond beacon, hey, I want to interact with a function that will allow me to swap this token for that, or mint GLP, or do whatever. And then the beacon says, okay, let me check in my mapping. Yes, that function is here, it is right at this address, returns the address, the proxy makes a delegate call to that address, and voila, it works. By doing so, we combined two patterns, which allowed us basically to be, in a way, future-proof. What I mean by that is that you can, with this architecture, pivot, change the implementation pretty much arbitrarily. Of course, there are like some limitations, as always. However, what happens is that you can change the way your protocol is designed, add new integrations, remove some integrations, add some bug fixing, do this and that. And we know that DeFi changes, right? Like, whole world changes, but the speed, the rate at which basically DeFi changes is astonishing. Like whatever was a new trend 6 months ago, it's not anymore. There is a new thing, there is a new protocol. And we knew that we need a way to scale infinitely, basically, in theory, infinitely, like not being limited by the maximum smart contract size. And we also knew that we'll be in need of being able to add new functions, remove them. This architecture allows us to do just that. So all in all, proxy patterns, proxy design patterns, diamond, simple proxies, any combination of those is something that lets you go beyond the traditional one contract that you interact with. It lets you build, upgrade, innovate, and pivot. It makes you, in a way, future-proof. And I strongly believe that either this, or maybe in a couple of months, we'll come up with a new standard, with a new design architecture that will be even better, will allow new generation of protocols to emerge and to pivot and to innovate and to bring new value as the DeFi changes, as we change, as the protocol changes. That would be that. Hopefully I explained it quite in a way that is understandable. However, I do get that it can be a bit confusing. When I started with it, it took me quite a lot of time to wrap my head around it, how it actually works. And I know it's a lot of information. So it so happens that we do have a couple of minutes for any questions, if there were. Let me know if there are any questions. Yep. Oh, there's a mic.
Hi, thank you for presentation. So when I was implementing upgradable smart contracts and I was trying to design on the pattern, of course there was a specific case in my situation, but I decided like to use universal upgradable proxy pattern because OpenZeppelin and Hardhat, they already had libraries and it was very, very easy to implement. Diamond proxy seemed much more complex to implement first. So what was your experience like? Did you have any learning curves when you were implementing it?
Yeah, so one of the things that I would say was super helpful for me is, by the way, I do agree that there is a higher level of complexity, but also it allows you to do more, I believe. And for me, what helped me the most to wrap my head around it was there is a guy named Nick Mudge. I hope I didn't butcher the pronunciation.
It's okay, yeah.
Yeah, and basically there is this GitHub repository when he presents you with different implementations of the same diamond standards, which either are more gas optimized or maybe more complex. And this is what I found really useful to work with. And at the same time, it was the thing that let me build upon and checked all the marks that we needed in our protocol. But I do agree with you on this point. If you know what are exactly your needs as a protocol, I would choose the simplest solution that checks all the marks that you need. Because there is no point in doing like complicated or complex architecture just for the sake of making it complex. I don't know if you know, like I come from Python background originally in Web 2, and there is like this Zen saying like simple is better than complex, complex is better than complicated. So I do agree, like the OpenZeppelin, they also have those universal proxies. I think like for us, they didn't quite work with everything that we wanted to achieve, but to anyone listening here or live, like make sure like you know how it works, read the docs, and if that will be something like good enough for you, definitely go for it.
Yeah, so learning curve, how long did it took for you to implement?
All right, so learning curve and implementation, I would say those are like two different things. So initial learning curve for me was that we started in our alpha version of the protocol with only beacon proxy pattern, and that took me, honestly, I don't remember, but it was probably like a week or two of like experimenting, seeing what actually happens, debugging, stuff like this. Then I was like, okay, I do understand it. And we did release the first version with the beacon proxy pattern, no diamonds yet. But then we realized soon that there are so many integrations that we need to add. So I also needed to learn diamonds. So I started exploring, reading articles, GitHub repositories, and diamond for me, initially, it was like much more complicated. So I would say I probably spent like a month just experimenting with it. Of course, it is possible to get this repo, clone it, make it kind of work, adjust it, and you're like, okay, I have a working diamond. But to like fully understand it, I would say spend as much time as you need. Would it be a week or a month? And then like implementation phase, where we like moved from the beacon proxy pattern to diamond, that took like maybe half a year. It wasn't that we were like solely focusing only on this. There were like also other parts that we were building out, but that was a big process, and it took us like months to actually get it right. But looking back, it was like an investment, because thanks to that, now we are basically able to integrate new protocol like every 2 weeks, or like add a new feature because of the high upgradability and like granularity at which we can like add, remove, edit functions. Oh, definitely, yeah. Thank you for the question. Yep.
Yeah. I wanted to ask about kind of the experience from a DevOps perspective. It seems like the diamond pattern has a bit more of a tedious work to actually upgrade, whereas with like transparent upgradable, you're just like changing the implementation address versus like, let's say you change the function signature. In the case of diamond pattern, you need to like overwrite the slots in the mapping. It just seems like there's a lot more steps involved, and it's easy to make mistakes. Do you have any insights on like kind of automating that process, or like how have you gone about doing that upgrade?
All right, yeah, this is a very good question. So I would say it depends, and yes and no. Like I do agree that of course upgrading diamond is a bit more complex than like a simple proxy where you just like change the address. And when it comes to automating that part, we are still on the way to like fully automate it. But the way like we went about it is basically when you make, it's called diamond cut. In transaction, basically, it's like a diamond and you cut it, so like add new facets, remove or change the existing ones. All you do really is like you submit a transaction with an array of objects of a type diamond cut. And the diamond cut object is basically three things. First of all, it's a 0, 1, or 2 value. It's like add, remove, or replace. Secondly, you supply the address at which that implementation contract resides. And then you, as a third parameter within that array, you supply another array. This is array of like 4 bytes of the selectors of the methods that you're adding. So if you want to, let's say, add 2 new methods, you would create an array, use 1 as the value to add. 0 is add, 1 is edit, and 2 is remove, or something like this. Check, non-financial advice. And then basically you are saying, okay, I want to add at this address, this and this and this method, so like the selectors, or remove them. And when it comes to like working with it, because if you have like, 5 minutes, all right, I'll try to speed up. If you're working with it, of course, if you have like bigger protocol, more methods, it's easy to kind of get lost, like what you have or not. So currently what we do, like first of all, Diamond standard, it exposes special methods like a loop, so-called, that you can inspect the diamond. So you can say, hey, return all of the selectors of the methods that are currently supported. And then when you have a selector, you can ask, hey, for this selector, what is the address? So it is possible to interact with the view methods of the contract to basically like read exactly what is there. And what we additionally do is we have like an amazing spreadsheet in which we have like, address, method selector, which protocol is it from, and where is it implemented, is it added, is it active or not. But I definitely see like a lot of possibilities of like automating this stuff. So for us, it's not like we do upgrades, you know, like on daily basis. It's probably like every couple of weeks, maybe every 2 weeks. So that works. But definitely making it more robust and automated would be a good thing. We are still on our way there. However, given that we have this loop functionality where we can like basically call on-chain, see what is there, what we want to add, is definitely not rocket science. So I would highly encourage it. And we're also doing that as we speak. Well, not as we speak, but now. Thank you very much. We have 4 minutes left. If there are any other questions. And it so seems so that there are no other questions. Thank you very much. Enjoy your day.